In today's lesson, we will learn how to find the area of a sector of a circle. What is the sector of a circle? Anytime we cut a slice out of a pumpkin pie, a round birthday cake, or a circular pizza, we are removing a sector. A sector is created by the central angle formed with two radii, and it includes the area inside the circle from that center point to the circle itself. The portion of the circle's circumference bounded by the radii, the arc, is part of the sector. Acute central angles will always produce minor arcs and small sectors. When the central angle formed by the two radii is 90 degrees, the sector is called a quadrant because the total circle comprises 4 quadrants or fourths. When the two radii form a 180 degrees, or half the circle, the sector is called a semicircle and has a major arc. Unlike triangles, the boundaries of sectors are not established by line segments. You do have two radii forming the central angle, but the portion of the circumference that makes up the third side is curved. So finding the area of the sector is a bit trickier than finding the area of a triangle. The distance along that curved side is the arc length. You cannot find the area of a sector if you do not know the radius of the circle, but you may be able to find the radius if you have either the diameter or the circumference. You just have to do a little preliminary mathematics to get to the radius. Given the diameter of a circle, d, the radius, r, is r equals d divided by 2. Given the circumference of a circle c, the radius is r equals c divided by 2 times pi. Once you know the radius, you have the lengths of two parts of the sector. You only need to know arc length or the central angle in degrees or radians. Now let's go over the formula to find area of a sector. The central angle lets you know what portion or percentage of the entire circle the sector is. A quadrant has a 90-degree central angle and is 1/4 of the whole circle. A 45-degree central angle is 1/8 of a circle. Those are easy fractions. But what if your central angle of a 9-inch pumpkin pie is 31 degrees? This formula helps you find the area of the sector if you know the central angle in degrees, and the radius of the circle. A equals in degrees divided by 360 degrees times pi times r squared. Replace in degrees with 31 degrees and r squared with 9 inches. So you have A equals 31 degrees divided by 360 degrees times pi times 9 squared. When simplified, we get A equals 0.0861 times pi times 81. Now we solve the equation, and our answer comes to A equals 21.91 inches squared. That is how you find the area of a sector of a circle if you are given the central angle and the radius. If instead of a central angle in degrees, you were given the radians, you use an even easier formula. To find the area of a sector with a central angle theta radians and a radius, the formula is A equals theta divided by 2 times r squared. It appears pi has disappeared, but it hasn't. Radians are based on pi. A circle is 2 pi radians. So what you really did was replace in degrees over 360 degrees with theta divided by 2 times pi. When theta divided by 2 times pi is used in our original formula, it simplifies to the elegant theta divided by 2 times r squared. You can also find the area of a sector from its radius and its arc length. The formula for area of a circle A with radius r and arc length L is A equals r times L divided by 2. Here is a birthday cake, 6 inches tall with a diameter of 10 inches. You can cut it into 16 even slices. How many square inches of the top of the cake does each person get? Each slice has a given arc length of 1.963 inches. The radius is 5 inches, and if you plug those numbers into the formula, you get A equals 5 times 1.963 divided by 2. which gives us an answer of A equals 4.9075 inches squared.